Hello, I'm Thomas O'Rourke, and I'm a tutor sponsored by the Office of Student Success for TSDC's AC Circuits. Next, I'm going to go over capacitors, a small component used in circuits, AC or DC, to store electricity in an electromagnetic field. In this slide, you'll see the dielectric, which is a non-conductive material in between two plates of metal with connecting leads. On the right side is the diagram symbol for your capacitors, represented by a C. Although the dielectric does not conduct electricity, it does allow lines of force and magnetic field to push through. So when you charge up a capacitor, in this case with a DC power supply, the lines of force can pass through, but the positive and negative electrons will not be able to go across, therefore storing the electricity because of the electromagnetic field. When the power supply is removed, you can use a capacitor to give a brief supply of power to whatever component you're using. We're going to go over a few of the types of capacitors. On these next few slides, you'll see the general construction on one side and a physical visual representation of the actual component on the other. This is a mica capacitor, one of the most inexpensive and widely used capacitors. Another type of widely used capacitors are ceramic. This is a ceramic disc. Although this is a ceramic disc, it also comes in other forms. So this is more of a square brick format, but is still made up with ceramic tiles in between the electronic plates. The last construction we'll look at are plastic film capacitors. Plastic film capacitors are rolled plastic in between two pieces of conductive metal. Here you will see in the cutaway view the several folds of the plastic and metal compound. The leads are then connected to the plates of metal, and you can hold electricity in the electromagnetic field. These are usually the most compact. They do hold a high amount of electricity, but are prone to damage from electrical surge. Some more of the types of circuits we go over are series capacitors, which you see here on the left, and parallel capacitors, which you see on the right. From capacitors, we get into RC circuits, which are resistive capacitive circuits. Resistive because they contain a resistor, so there's our R, and capacitive because they contain capacitors. So we have RC circuits. Like our other components, RC circuits also come in parallel and series form. In AC circuits, we calculate for missing variables, we predict outcomes of voltages, and are able. Thank you for watching. This is Thomas O'Rourke, tutor for AC circuits from TSDC, sponsored by the Office of Student Success.